Hello, student. Go to the teacher's website. Now you should go to the application of Python Artificial Intelligence in Business Focused. You open the chapter 6. Today our topic is here is the deep learning regression prediction. We use the KRAS module for deep learning. We begin a six step to build a neural network with the one nonlinear for a linear regression model to predict y by given x. And we should to do all that. And not because that the objective of this is just to use the I think that we should to do something for we need to transfer that to English first, you know. But first that we should to find. Let us to check that whether we can code of that. Okay. Here this is our objective of that. And we should code of that. And the objective of this text is to complete the full implementation of deep learning regression problem. And the additionals include four approach. The first approach is automatically split the entire data set DF into two groups for training data trained and testing data test, and also plot the historical loss value during training history, and also evaluate the module's performance using the evaluate which return to value, loss, and a matrix indicator. The fourth is to determine whether the module is overfitting. Overfitting that the loss test is significantly greater than the loss trend, and the gap continues to widen. Okay, here is that our fourth step. No, that is seventh step. We have the seven introductory steps for deep learning linear regression. And here this is our objective. The objective of this is using the Keras modules in deep learning and build a neural network with a single neuron's linear regression module in 4 simple steps, and first train the model on S data, when then input a S value and finally predict Y. And we should to do our first step is to do like this. And here is our practice. And the objective is to do the linear regression of that, like this. So we execute the command of that like this. And here that finally we'll do our purpose of that, just for that. Perform linear regression prediction and predict when x is equal 10 and what is the value of the y. Like here, this is this problem, and we execute command like this. And but the next second we should to split the data. We should to split the df into 4 value. And this 4 value include the S-train. Okay, we execute command S-train, S-test, Y-train, Y-test. We do the split. You can see the split data like here, split data. And then we output the X-test like here. Okay. But for the neural network, we have the fourth step. Here, this is a simple fourth step for the neural network. The fourth step is to build a mathematical model. And we should to build our this is our first step. Is the build the mathematical models, and the command is just like here. Okay, I build a model. We have only one unit, and our input dimension is 1. Okay, but you know that we have some simple regulation. Here is our simple regulation. We should to set up the optimizer loss function and also the activation function. And here this is our second step. And you know that since this is our second step, he will configure the three mathematical functions of the neural network model. We use compile the model, and these three functions include optimizer, loss, and the matrix. And we do execute command like here: compiler, optimizer, loss, and the matrix. Okay. And here then we go into the step 3. And for the step 3, that is learning the data. You know that we should to learn the data use the model feed to learn the data. And you know here that you use, okay, it will take a lot of time to do this, right? Okay, so we should wait for this. And for the step 3, that we train the model using the historical data. And the totals, the 200 or 2000 epochs are expected, executed, and repeated is marking new guesses and validating whether they are close to the correct solution. And we'll do the experiment when the numbers of the training epochs is set to 200 and 1000, 2000 and 4000, and to compare what difference can be observed in the prediction result. And we can see that here he will just to input. So now we should wait for this. And before we wait for this, we can do the next step, and that is the step 5. And for the step 5, that is the okay. Let us to see that okay, he is still running the programming code. And for the next step, okay, for next step, that is the plot the historical loss value. And history 1, that is dictionary format. So it must be first be converted into a data frame before plotting, like here. Okay, we just to plot this like here, and we should transfer into the data frame first, and use this to plot as a data frame. That is a loss function, right? And here that we can see the results like here. Here that is our result. Because it is executing, okay. So that will be delayed over lag because that is executing here. And it's observed that when after epoch bigger than 500, the loss no longer decreases. Therefore, the number of epoch can be set to 100. It's no need to set to 2000. So I think that I should to change over this into the other one. Otherwise, that in the future that will waste a lot of time to do all that. That we since now we doing that is the 6 the example 6-10, right? So why let the answer okay? So I should change of that with this, right? So maybe later I have changed not correct one, right? Alright. Maybe later I should change again. Here let the number of here I should change to 1000 will be first. And don't forget that you have this and that you must to change of that by the other one. Still that SQ now. And don't forget we have the 7th step. Here this is our 7th step. Here that is our objective. You will shift, right? Never mind if we occur the objective shift. And here that is introduced for the artificial, right? What is artificial? And then we just that is a single one description for the neuron. You only can deal with one unit neuron cell. Okay, and then we go to our practice one to load the data set, right? Here that is our data set. Go to our first step of the data set of that. And we also show the objective of this exercise is perform a linear regression prediction. Predict what? When x is equal 10, predict the y value. And here the second step later is for the split data. We should split df into 4 value. And after that we do our simple 4 step of the deep learning neural network. Here this is 4 simple step. And here this is for our 4 step. And but we have some simple regulation for here. Here this is our simple regulation. And then we do the step 2. Step 2 is just to set up the 3. Later we set up our okay, here that is our, so you have step 2, right? So maybe sometimes we will do not the correct one, right? Here this is step 2, but here this is not correct. Here is just simple regulation. Our simple configuration rule. So I should to input the simple regulation rule. Okay. And you know that after that we do to learn the historical data set. We have to do that just now for this. We just to let it do the train the model using the historical data. Historical data for this. Okay, and then you will do to learn. After you do this, then we just to show the historical data of the to plot of that. So now I should just to plot the data of that. That is step 5. And we plot this, and we also show the result of that is just like here. And for the step 4, we do the prediction. After we do this prediction, we can see that if we do the prediction, we can do the prediction of the value is 20, right? When x is 10, then y equal to 20. This is my prediction. And but then I should to redo, modify of that model due to some. Okay, I must to modify parameter and perform testing. Why I will do this, I will explain. Okay, I want to modify parameter and perform testing. After modification data, all steps must be re-executed, and the partial re-execution is not allowed. Okay, I will do all of that, and first of that I should draw the plot. To plot the curve first, I plot the data now. After I plot the data, then I will just show the data just like here, you see. And then I want to evaluate the accuracy of the model. You know that I should execute. Okay, I execute evaluate the model's performance using evaluate function, which will return two value loss and the matrix. So the command is just like here. Model evaluate for the train data, it will return loss and the matrix of that, and the output just like here. And then I should to evaluate that whether the problem of fitting is occurring. For regression problem, evaluate whether overfitting occur by comparing the historical data of loss train and the loss test. So after I compared of these two values, then I could understand whether that the data have the overfitting phenomena. And you know that after you do like here, this, And the objective is for a regression problem. We will evaluate whether the overfitting occurred, and we will compare the historical data of loss trend. And it will return loss and the matrix. Here, this is the loss like here. And we will return the data for the test data. The loss is just like here. And evaluate whether overfitting occurred by comparing loss of these two values. And because that the loss test is significantly greater than the loss trend, so I can make a conclusion that and the gap continues to widen. So, but although the loss test is bigger than old trend, it is still necessary to evaluate whether the difference between the loss test and the loss trend keep increase. Therefore, the loss curve must to be plotted. So now then I should draw the curve of that. And then the objective of the exercise 8 is to plot curve. So it's necessary to return the model using S-test and Y-test to obtain the historical loss data. And then I rebuild the model again, set compiler 3 parameter again, and to train the data again. Finally, you will get the data. After he learn the data, he can predict and to draw the map like here. Here is draw the map. You can see there's a curve. Here is for the train data, for the test data. And now we will to identify whether the overfitting occurred. He said that you should to how to determine whether the overfitting occurred. And for condition and overfitting, because the loss is significantly greater than the loss trend. So, and the gap is continuous to great. So, for the inspection result, it seems loss test does not gradually increase, and that is loss test gradually approach to loss trend. So, therefore, no overfitting phenomena is observed. Here that is our conclusion for this exercise. And now you can find that okay, the same, right? Here's the same. Not the same. You have the shift. So sometimes it will make me confused. Due to the shift, so sometimes I will copy the wrong code. It's so dangerous. Okay, our conclusion is the model's function setting for regression problem and for the linear problems does not require set an activation function. For the nonlinear problem requires setting the activation function. For the second conclusion, using the Keras neural network module with a single neuron To handle a linear regression problem, we have 7 steps. And for step 1 is build a mathematical model first. Second is configure the 3 mathematical function for neural network model. For step 3 is train the model using historical data. For step 4 is perform prediction. For step 5 is plot the historical loss function. For step 6 is evaluate the model's performance, which return two value, matrix and loss. Okay, student, now you have the 5 minutes to practice of the code by yourself now.